Good morning students. In the previous lecture we have seen about the definition of Fourier series, Differential conditions and formula for 0 to 2 pi, and based on that we have seen some problems also. So in this lecture we are going to solve problems in 0, 2l limit. So here the question is find a0 and an for the function f of x equal to x in 0, 2l. So what is the formula for a0? So a0 is given by the formula 1 by L integral 0 to 2L f of x into dx. So which is equal to 1 by L integral 0 to 2L. Our f of x is given as x. So x into dx. So which is equal to 1 by L into integral of x. So when you integrate x, you get x square by 2 between the limit 0 to 2L. So which is equal to 1 by L into, when you apply the upper limit, you get 2L the whole square divided by 2, and when you apply the lower limit, it will become 0. So which is equal to, so 2L the whole square is nothing but 4L square divided by 2 into L is 2L, and this becomes 0. So 1 2 gets cancelled and 1 L also gets cancelled. So the answer is 2L. So the value of a0 is given by a0 is equal to 2L. Next you have to find the value of an. So an is given by the formula an equal to 1 by L integral 0 to 2L f of x into cos n by x by L into dx. So it is equal to 1 by L integral 0 to 2L. Our f of x is given by x. So x into cos n by x by L into dx. So when you have product of two functions, so you have to integrate this by using Bernoulli's formula. So what is Bernoulli's formula? So Bernoulli's formula I is given by u into v1 minus u dash v2 plus u double dash v3 minus etc. Here you have to choose u as x. So u equal to x and v is given by cos of n pi x by L. Here u represents the differentiating function and v represents the integration function. U dash is given by, when you differentiate x you get 1, and u double dash equal to differentiation of a constant, it becomes 0. Similarly v is nothing but integration, so v1 is equal to integral of cos. When you integrate cos you get sine, so sine of n pi x by L divided by the coefficient of x is n pi by L. Similarly v2 is equal to integral of sine. When you integrate sine you get minus cos, so minus cos n pi x by L divided by n pi by L. Already one n pi by L is here, so n square pi square divided by L square. So you have to multiply u into v1 and u dash into v2. So u double dash is 0, so no need to find v3. Let me substitute it here. So an is equal to 1 by L into u into v1. So u is nothing but x into v1 is sine of n pi x by L divided by n pi by L minus u dash into v2. So u dash is 1 and v2 we are having one minus sign. So minus into minus becomes plus cos of n pi x by L divided by n square pi square by L square, and the limit is 0 to 2L. So sine term, when you apply the upper limit 2L, L and L gets cancelled and sine 2n pi is 0. Similarly when you apply the lower limit also it becomes 0. So sine term will get cancelled for both the limits. For cos term let me apply the upper limit. So 1 by L into, so this term when it comes to the numerator it becomes L square by L square pi square into cos of, when you apply the upper limit 2L, so L and L gets cancelled, you get cos 2n pi minus the lower limit, when you apply 0 it will become cos 0. So what is the value of cos 2n pi? Cos 2n pi value is 1. Similarly cos 0 value is also 1. So that is, here one L gets cancelled. So which is L by n square pi square into 1 minus 1. So 1 minus 1 is 0. So the value of an becomes 0. So an is equal to 0. Suppose if they ask the value of Bn, you have to find this similarly using the same formula 1 by L f of x sin n pi x by L into dx. After finding a0, an and bn, you have to substitute everything in the function f of x. Hope you understand. Thank you.